So I'm going to share with you some results of our studies that we've been doing over the past 14 years here at UCSD, looking at adolescents and their brain in relationship to substance use. So I'll talk with you a little bit about how widespread substance use is, what we expect to occur in a healthy adolescent brain during development, and some of our studies have looked at how substance use during adolescence might affect the brain. And then finally, some of our research looking at certain neural markers that might point us in at certain factors related to risk versus later substance use in youth. So national epidemiological survey data show us that, fortunately, in our society, not too many early adolescents have used substances, a few have at the beginning of adolescence. But as we move through adolescence and get to like 12th grade, quite a few kids have used substances on a fairly regular basis to get them high. And the most commonly used substances over a large period of time are alcohol and marijuana. This continues into the college years as well, with even higher rates by that point in time. Smattering of other substances are a cause for concern as well. In recent years, we have quite a few kids who are misusing narcotics or opioid pain medications. That is, using other people's prescriptions or taking their own prescription other than as prescribed. And then some other substances kind of come and go throughout the years. But alcohol and marijuana are by far the most widely used, and that's what the focus of our research has mostly been on. So during this time in life, when young people begin to experiment with and sometimes progress into substance use, is the same time in life when there's a lot of changes occurring in the brain. So from certain ages, sort of 12, or puberty, on through teenage years, and even through the 20s, there's quite a few neuromaturational processes that we're anticipating to occur in the brain. And one of these is myelination, so there's kind of progressive myelination of the axons, and this is still happening in kind of frontal-parietal connections throughout the teenage years and even through the 20s. And then in the teenage years, there's quite a lot of synaptic refinement occurring, which results in the cortex becoming thinner and actually a reduction in gray matter volume. And this last point is kind of illustrated here by some research by J.B., where we see that for boys, their lifetime max prefrontal cortex volume happens when they're about 12 on average. There's a lot of individual variability. And the same process occurs for girls, but it happens about a year or two earlier. So there's a lot that we're anticipating to happen in the brain during adolescence, and at that same time in life, it's when young people are engaging in a lot of behaviors that could potentially adversely affect these processes. So since the 90s, we've been doing some studies. These were in collaboration with Sandy Brown. We did a lot of neuropsych studies. We were looking at kids who were in treatment for alcohol and drug problems, trying to figure out, gosh, does using these terrible things so often actually do anything we can see discernible that's negative to your thinking and memory abilities? And we found that there were some things that were not going great for the kids who were using a lot of alcohol and drugs. We saw that for kids who were drinking heavily, they tended to perform more poorly on tests that required visual spatial functioning, also working memory tests, and also their ability to retrieve information accurately appeared compromised. In kids who are using marijuana heavily, we saw that they tended to perform more poorly on verbal learning tasks. But we've generally seen that that often rectifies after about 30 days of abstinence, as studies with adults have seen as well. So these neuropsych studies really help to inform our fMRI studies and led us to want to look inside the brain of young people to see what's going on in there. Are there activation patterns that kind of subserve these abnormal neuropsychological performances? So we were very fortunate to be here at UCSD when we had an excellent imaging center and capabilities even at a pretty early phase in this line of research. So our first kind of hypothesis was basically, does using substances during adolescence adversely affect your brain in some ways we can pick up on? We did a series of cross-sectional studies where we compared groups of kids who were substance users and non-substance users on a variety of different fMRI tasks. Some of these studies we did back at Thornton, some were done at the VA, and some of them have been done at the Keck Center here. And we've generally seen that for adolescent substance users, there they're generally showing more activation as they're doing a variety of cognitive tasks. But these were cross-sectional studies, so we really didn't know if these were effects of the substance use or if these were some kind of markers that predated the onset of substance use. So we started some longitudinal studies to help us better tease apart the sequence here. And in 2002, we were fortunate to receive funding from NIAAA to start a longitudinal study where we got kids from kind of normal middle schools here in San Diego, 13 and 14-year-olds, and we gave them neuropsych testing and brain imaging, and we got about 300 such kids enrolled in the study. And then we do annual follow-ups where we have the kids come back, do the same testing, the same brain imaging, the sequence, but as the years go by, some of the kids remain non-substance users, and some of them progress into heavy levels of substance use. So it makes for a really nice study design where we can compare changes in the kids who progress into substance use as compared to those who remain substance users, but we know what their brain functioning was like before they ever started to use substances. We also try to really be able to isolate a whole host of factors, there's so many things going on with young people, to the substance use specific features as much as possible by excluding youth who have a history of psychiatric conditions, neurological problems, history of traumatic brain injury, so that we were able to focus on the substance use. And we also oversampled kids who had a risk factor for progressing into substance use. So kids who have familial alcoholism or who have got to a little bit of trouble, a little bit of conduct disorder, because those kids are much more likely to start using, and that helped us to observe sufficient numbers of kids with heavy, clinically notable levels of alcohol and other drug use. Now, one of the tasks that we've used in our fMRI studies to help us look at the effects of alcohol and drugs long-term on kids' brain functioning is a spatial working memory task that Greg Brown and Sandy Kinderman developed here years ago. And we found it to be quite a nice study, quite a nice task to use because it yields a pretty consistent activation pattern. It's a block design task, and it has two conditions, a hard part, which is memory for locations, and then an easier part, which is kind of a simple vigilance task. And we're basically looking at activation to the spatial working memory condition relative to activation to the simple memory, simple vigilance condition. Here's a study that was conducted by Lindsay Squiglia during her graduate work here. It's a cross-sectional study of 95 adolescents, some of whom were binge drinkers, some of whom were not binge drinkers. But in this study, we had the ability to look at boys and girls, which was really unique. In this study, Lindsay found that for male binge drinking 16 to 9-year-olds, as they did this spatial working memory task, they tended to show more activation in a range of areas that are important to the task as they were trying to remember the locations in the task. So a lot more activation needed to do the task, which is consistent with what we've seen in a lot of studies of young substance users. But here we had the sufficient sample size to be able to look at female binge drinkers, and we found that the female binge drinkers actually showed less activation as they were trying to do the task. And importantly, for the female binge drinkers, less activation to the task was associated with poor performance on neuropsychological tests, including this test in particular, the digits vigilance task, where it took the girls who had less activation in some frontal, parietal, and temporal areas, it took them more time to complete the task. So it indicates that there's a clinically significant feature to this activation pattern. Importantly, we've started to do some longitudinal fMRI studies now, where we're looking at activation patterns at one point in time in relation to activation patterns later. So in this study, we're looking at kids who at age 13 were non-substance users. We gave them Martin Hollis's go, no-go task, so we could look at inhibition-related activation patterns. And then as time went by, we looked at their activation patterns later. We saw that in kids who remained non-substance users kind of throughout adolescence, they showed a pattern of a high level of activation in early adolescence in this frontal area as they were attempting to inhibit responses. And as time time went by, they showed less activation in that area. And that's a fairly typical kind of a response with adolescent neuromaturation, where there's less frontal activation needed to accomplish the task. But in the adolescents who progressed into substance use, we saw a very different kind of pattern, which was most notable, really, for looking at their activation pattern before they ever even started to drink. So these kids, before they even started to drink, demographically were pretty indistinguishable from the kids who were going to remain non-drinkers, but they had a very different activation pattern. They were not activating this frontal area very much as they were trying to inhibit responses. They did just fine on the task, but they had a very different activation pattern. And then, years later, they started to drink, and they showed an increase in their activation to the task. So a higher level of activation. And in fact, the more that they were drinking, the more there was an increase in their activation to the task as years went by. The more kind of neural effort was needed for them to successfully inhibit responses on this task. A very similar pattern was seen in the dissertation work of Lindsay Squiglia, which is using a visual working memory task with a similar kind of a sample of kids. And we see here in this task that, again, the kids who are going to remain non-substance users show a high level of activation in these frontal and parietal areas as they did the task. And with a healthy adolescence, the activation needed to do the task decreased with time. But a very different kind of pattern in kids who were going to go on to drink heavily during adolescence. Where when they were non-drinkers in early adolescence, they showed much less activation to do the task for this working memory task. And then as time went by, they required more activation to do the task. Now, these studies were focused mostly on mostly on alcohol use, although when you look at heavy drinking youth, there's usually some marijuana use in the mix. We've also done studies that are focused on marijuana use, although most kids who use a lot of marijuana are using some alcohol too, so it's hard to completely disentangle it. In this study, we had kids who were pretty heavy users of marijuana. We asked them to not use marijuana for 28 days before we monitored this with serial urine tox screenings. And we found a kind of similar activation pattern as we've seen in some of our other studies where adolescent substance users are showing more activation as they're doing the task. In this case, it was an inhibitory task with a lot more activation from the parietal areas as they are inhibiting a response. So to summarize what I've shared with you so far, we know that the brain is still developing through the 20s. There's still quite a lot going on in the teenage years, and some of those processes are continuing to occur through the 20s, at a time in life when substance use, emergence, and escalation is quite common. Secondly, we see that substance users tend to show some abnormalities in features of brain response to a variety of fMRI tasks. But we really don't know for sure if that is caused by the substance use or if that relates to features that were in play before the substance use began. And we've also seen that there seems to be a particular risk for females. We see these effects in male and female substance users, but the effect sizes are usually a bit larger in adolescent female drinkers. And also, for the kids who are drinking to the point of experiencing a hangover effect or some kind of a withdrawal, we often see that the effect sizes are most notable there. So those are things like if the young person's drinking so much that they have a headache the next day, or they're feeling lethargic or irritable, those are all kind of signs that the person may have drank enough to adversely affect their brain. So next I'd like to share with you some of our findings that are focused on looking at neural risk factors for progression into substance use later. We know that a family history of alcoholism is a major risk factor for personal substance use problems later. So people with a family history of alcoholism have about a 2 to 5-fold increased risk of developing a substance use problem in their own life. So it's one of the most marked risk factors. In this study, we looked at 20 kids with a family history of alcoholism compared to 20 very closely demographically matched youth without a family history of alcoholism. We compared their activation during a visual working memory task. But in this study, we did kind of a functional connectivity kind of analysis during a task. We looked at C regions that we know are critical to doing this task, right and left dorsolateral prefrontal cortex and posterior parietal kids with a positive family history of alcoholism showed poor connectivity between the frontal to parietal nodes, but surprisingly did not show any kind of white matter microstructural abnormalities in the white matter that's sort of subserving those connections. We've done a few studies longitudinally where we're looking at brain activation patterns in relationship to subsequent substance use. And in this study, we gave a go-no-go task when the kids were 12 to 14 years of age and had no history of substance use to this point. And then we followed them up later, and we found that the kids who went on to use substances in the subsequent 3 years showed much less activation when we look back in time at their activation pattern to this inhibitory task. So kids who were going to use substances later showed much less activation in all of these brain areas prior to the onset of substance use. And then in this other study, we looked at kids who already had patterns of substance use going on, and we looked to see if their activation patterns to the same go-no-go task, and if that would predict progression of substance use later. And we saw that it did. We saw that overall for kids with kind of a wide range of substance use patterns at the project baseline, there was a prediction to later substance use based on less activation in this brain region during inhibitory trials of this go-no-go task. But this relationship was particularly strong for the kids who already had a heavier frequency of substance use at the time of the initial imaging session, so that the kids with the lowest goal response patterns were more likely to have higher drug dependence counts in the 18 months after that imaging session. Now, we've used fMRI to look at another way to look at young people's substance use patterns, and that is to look at alcohol advertising and kind of cues in the environment. So there's all kind of cues in our environment that remind us to maybe do things that aren't good for our health, and alcohol is one of them, potentially, and certainly for young people. With alcohol advertising, we know that the more ads that a young person is aware of, the more positive views they tend to hold about alcohol, and the greater the plans they have to drink as a grown-up themselves. The more that young people like ads, the more likely they are to drink. And especially young people like ad campaigns for alcohol that contain humor and stories and animals. And a lot of the breweries have capitalized on that by using animals in their ad campaigns over the years. So to look at this kind of from a neural perspective to see what's happening in the brain as young drinkers and non-drinkers are looking at these kind of stimuli, we put together an alcohol pictures task where we did this in 2000, back when people looked at magazines. And we cut out pictures of advertisements from magazines with high youth readership rates, alcohol ads, and non-alcohol beverage ads. And we showed these pictures to the kids one at a time as they were in the scanner. Half the kids had a history of heavy drinking, half had only tried alcohol once or twice. And we saw pretty notable differences in the brain activation patterns between these two groups of kids. The orange areas show you where in the brain the kids who were heavy drinkers showed preferential increased activation as they were looking at the alcohol advertisements relative to the non-alcohol advertisements. Their brains were lit up as they looked at those alcohol ads. In contrast, the kids with pretty minimal drinking experiences didn't have very much neural differentiation between the two stimuli types as they were progressing through this task. The more that a young person was drinking, the greater the degree of differential brain response as they're looking at that alcohol. So these kids here who are drinking, more than 80 drinks a month, which is a lot if you're 17, really their brains were really firing up, especially in a lot of visual attention areas as they looked at alcohol ads. Carmen Polito here in our Department of Psychiatry at UCSD has really taken this to a whole other level and has created tasks that are looking at other substances too. So looking at pills that can be used, marijuana, crystal meth, and other kind of powdered drugs, and other kind of further implementation of our alcohol cue task. And together in collaboration with a project with Martin Paulus, we looked at adolescents with substance dependence and how they respond as they're looking at pictures of personally relevant substance images. And Carmen found pictures of drugs that are the kinds of drugs they personally had taken. They showed activation in, I think, 27 out of 28 hypothesized areas, and there was just one area that kind of diverged from the hypothesis. A lot of these areas of activation, consistent with all of these studies really, and most studies in adults as well, are in a lot of brain reward areas and also areas in the interoceptive system. So we've seen a lot of insula activation in people who have a substance of choice. They're looking at things that look like their substance of choice. And Carter found that the greater the degree of insula activation, the more craving the young person reported having for their drug of choice after they came out of the scanner. So just one more task that I'll quickly share with you, which is a task that Martin Hollis designed called, we call it several things in the lab, a soft touch task. It's kind of a brushstroke task that's applied on the forearm and also on the hand. And the task is a stressful phase, and then a period of time where you're kind of told that this is going to be coming, and then a period of time where it is actually occurring, and you're feeling this pleasant kind of brushstroke on your arm or hand. We've given this task in quite a few populations now, but we've given it to adolescents with and without substance dependence. And interestingly, this is work by Robin McGreevy that is in progress. During the anticipation phase of the study, the adolescents with substance dependence show less activation than normal controls, but when it's actually happening, they're showing increased activation to this kind of positive stimulation. So we know that adolescence in general is a time in life when there's kind of increased reward sensitivity, and I think this is happening to a greater degree with some adolescents than with others. And particularly with adolescents who've started to use substances to a problematic level, they may have particularly high reward sensitivity that may still at this point be somewhat general to include not only the drugs of abuse, but other positive forms of stimulation as well. What may happen, though, is as substance use continues to occur and as development kind of solidifies, when you're an adult substance-dependent person, you might not have the same kind of activation pattern, where substance-neutral kind of positive things might not have much of an effect for you anymore. You only get that boost when it's something that's substance-relevant. So just to kind of summarize these kind of two lines of work, we do see some unique neural abnormalities that seem to follow heavy levels of alcohol and other drug use in young people. Especially we see these in kind of frontal parietal and frontal temporal areas. We can't really infer causality, but we're beginning a large multi-site study that will increase our ability to look at some of these things temporally and make inferences a little bit more carefully by being able to kind of look at the reversal of some of these effects. Effects are particularly strong for alcohol and for females. We also see that there's certain neuroresponse features that appear to be a marker for subsequent substance use in young people. A lot of these seem to be centered on the inhibitory system and possibly in the interoceptive system, which may point to these two systems as potential targets for intervention, and maybe ways that we can kind of bolster these systems or kind of help modulate people's responses there so that we can offset people's difficulty with resisting drugs. This is just to kind of highlight our new study, which we call Encanta. I won't state the abbreviation because I've temporarily forgotten. But it's a fabulous study, 5 sites, and we'll be collecting data on 170 kids here in San Diego and following them over time to address these hypotheses. We want to importantly thank our wonderful imaging center here at UCSD, which has made it possible and really exceptional to do this kind of work for many years, and the fantastic lab and colleagues here, and funding from NIAAA